Hello everyone, hope you all are doing well. In this video, we'll discuss a famous interview problem. Find first missing positive number from an integer array. The motive of this video is not to tell you the solution, but basically tell you how to approach this type of problem. Because again, this type of problem can have multiple approaches, and as you keep on adding the constraints, you will have to basically work on your mind that how can I devise a solution with the given constraints, right? So let's first see how do we start approaching this type of problem. Again, this is sort of for a beginner, because obviously if you are experienced that you then and or if you have seen this kind of problem, you know that okay, this is a particular solution for this problem. But if you are seeing this problem for the first time, then we will see that how one starts to approach this problem, and how that particular solution, a current solution, can be improved to a better solution, and what if some constraints are added while we are telling a solution. So how do we modify our solution, right? So we'll be basically following that approach, and we'll seeing that how we modify our solution. And this will be for all the, I would say, problems. This is just one type of problem, but again, we'll be following a similar approach in most of the problems, right? So let's start discussing this question. Okay, so the problem statement says that we are given an integer array. And we have to find the first missing positive number. Okay, and so and also a point is that 0 is neither a positive nor a negative number, right? So given an integer array, you need to find the first missing positive number. So let's look into some of the examples. I have written this before starting the video to save some time, otherwise this video will be a long video and probably it will bore you. So that's why. So again, if we look into the first example, then the first example is 1 2 3. Now we can see the first missing positive integer is 4, right? Because 0 is not a positive integer. The smallest one is 1, then we have 2, then we have 3, and then we have 4, but 4 is missing, right? So 4 will be answer in this case. Let's come to the second example. So it's 0 1 6 4 2 3. Now in this case, we can see what is the smallest positive number. Smallest positive number is 1. So okay, 1 is present here. What comes after 1? So 2 is also present here, 3 is also present, 4 is also present here, 5 is not present here. So that means 5 will be our answer in this case. Okay, here 4 will answer, and here 5 will be an answer. Now let's come to the third case. Okay, so in third case, let's search for 1. So do we have 1 here? No, we don't have 1. So in this case, 1 will be our answer. Now also the test cases tell you that you can have positive or negative numbers, like you'll have a flavor of both types of number. Okay, so that's pretty much all about the problem. Now let's now if you are seeing this problem for the first time, then please pause the video and try it yourself. Give 5-10 minutes, try it yourself, that how would you approach the problem. And again, it's not about the complexity. Obviously complexity matters, but if you are solving it for the first time, let's go for a brute force approach. Okay, and then we'll try to improve the solution. So please do pause the video and try to think it yourself. Okay, so what could be the first approach, the most basic approach, right? So approach 1. So if we look into this, so suppose the size of the array is n, right? Size of the array is n. So it says find the first positive missing number. Now in best case, what can my array have? It can have the first n numbers, right? Obviously in jumbled order or in whatever. So 1 2 3, something like this. So that means in best case, my array can have first n positive numbers. So in that case, my answer will be n plus 1, right? Like for example, if I have an array of length n, so the array can have 1 2 3, it can go up to n, right? So in this case, my answer will be n plus 1, right? So this is the maximum answer that is possible, right? Let's come to other cases. What could be the other cases? The other cases could be that okay, these are first n numbers. Okay, what if we remove some numbers? Like for example, we remove 3 and we add suppose 10 raised to the power 9 here. We remove, suppose here we have 10, we remove this and we add minus 100 here, right? So in this case we know what will be our answer. In this case we can see 3 will be our answer. And if the size of the array, suppose this is 100, or in terms of variable if we say this is n, so we can see here 3 is less than n plus 1, right? N plus 1, because the best case, in the case that can go in our favor is that all the numbers are in ordered are present from 1 to n. So in that case we will have our answer n plus 1. In all the other cases our answer will be less than n plus 1, where n is size of the given array, right? Got this point? So in that case how we will approach this one? Just a second. Yeah, selected this. So how we will approach this? So the basic pseudo code will be something like for from, so I goes from 1 to I less than equal to n plus 1, I plus plus. Now again we are talking about brute force approach. We'll optimize it moving forward. Okay, so I goes from 1 to n plus 1, and we have an inner loop for j goes from, right? J goes from. So what we are trying to do, we are trying to iterate for each number, right? We are trying to iterate for each number, and we are trying to see whether this number is present in the array or not. So what will happen here? J is equal to 0, j less than n, this is the size of the array, j plus plus. Now what we do, if array of j equals I, then probably we can take a variable here, boolean found equals to false, right? And as soon as we get this, oh just a second, as soon as we get this, what we do, we make found equals to true, and then we break, right? We break. So we come out of this inner loop, and outside inner loop will check if found equals false, right? So we return I as our answer, right? So we are starting from 1 and we are searching whether that is present in the array or not. Okay, whether that is present in the array or not. So we are checking for all the elements using this, and if we are able to find the current element, that is we are able to find I, so we change the value of this variable found equals to true, we break the loop, and after this loop we check if found equals to false. That means we were not able to find I in the loop, that was not present in the array, so we return I in this case, right? And what could be the other case? What could be the boundary case? The boundary case is we came out of the loop. So actually this will be a function, right? This will be a function. Otherwise at last what we can do, we can return n plus 1, right? So this is the brute force approach, because what happens, suppose we have first n numbers present, so this loop will run, it will complete the iterations, right? Will complete the nested iterations, and at last we'll return n plus 1, because for an array of size n we had numbers from 1 to n, so that means we'll return n plus 1. Now what will be the time complexity for this one? So the time complexity for this one will be big O of n square, right? I'm not going into the details, because again the outer loop is running for n plus 1, the inner loop will run for n, because the size of the array is n, so that goes to n square, right? So this is the basic approach that you will follow, right? What could be the other approach that we can follow, right? This is the basic approach. Again, if you came up with this solution by yourself, try to think how you can optimize it, right? So what we can do, we can probably approach 2. What we can do, we can take some extra space, right? We can take some extra space. What can be done, probably what we can do is that, so we have an array, right? We have an array. What we can do, suppose the size of the array is n, so we can take an extra array. Suppose we take a boolean array, having name is present, right? We can take this array which has a size of n. What this array will do, what we can do, we can traverse the array, the given array, and suppose we get element 1. So what we'll do, we'll go to is present, we'll go to the location is present, and suppose the current value is cur minus 1 equals to, we can make it true. Initially all the values are false, and what we can do, we can traverse our complete array, and as soon as we go to an element, we basically go inside our this boolean array, and we make it true that okay, this value is present. Now again, for indexing purposes, what we have done is that since we need to find the positive numbers, right, so we are omitting 0. So what we can do, if we get a value current, so we go to current minus 1 position. Now again, you can deal with current minus 1 or current. For simplicity, I have taken current minus 1. So you do this. Finally, what you do, you run a loop for I equals to 0, I less than n, I plus plus, right? Go down. If is present, I equals false. If this is false, then what you do, return I plus 1, right? Why I plus 1? Suppose we were having value 1. So what in our logic, what we are doing, we are going to 1 minus 1 position, that means 0, and we are making it true. Suppose we have a value of 5. So where we are going, going to 5 minus 1, that is 4th index, and we are making it true. So that means if we are at value I, and if it is false, that means element number I plus 1 was not present. So that is why we are returning I plus 1. Now again, let's come to the time complexity for this one. What will be the time complexity? So in the first iteration, what we are doing, we run a loop, we run a basic loop, and we just mark the elements of this array, right? We just mark the elements of this array, and in the second iteration, we run this logic that if it is false, then just return it, right? So in this case, our time complexity is big O of n. But again, we are taking some extra space, right? What about space complexity? It is again big O of n, because it depends on the size of the array. How many elements do we have in the array, right? So this is something that we are doing in this case. Now again, if you go with this approach, you can just see that what is happening here is that we are taking extra space which is proportional to the size of the array. Now what if our array is very large, right? Suppose our array is very large. So for simplicity, I'll tell you, suppose I say that okay, my array has, I would say, 10 raised to the power 7 elements. Obviously this will fit in memory, but taking this much of extra space is not good. What if I have an array, a big array, and all the values are 1 1 1 1 1 1? That means I have 10 to the power 7 values as 1. Or if I say my array has 10 to the power 8 values and all the values are 1. So actually what we are doing, we are taking an array of size 10 raised to the power 8, which is not an optimal thing, because we are dependent on the size of the array, but there is only one value present, right? So if our array is very large, then in that case, we will be facing problems. There could be constraints that okay, you cannot take this much of space, and that is not feasible as well, right? That your input is fitting into the memory, but the extra space that you are taking, it can create a problem for you, right? So this is not the best of the solutions, because we are dependent on the size of the array and not on the values present there. If I have a big array, irrespective of what values are present in the array, I am making the array of that size. So again, not a good approach to follow. Obviously it will run, but it will not be performant, right? So again, what could be another approach? Let's go to approach 3. Now in the previous solution, what we did, we were taking a boolean array, right? Boolean array of size n, where n was size of the array, right? So instead of doing this, why don't we take a hash map, right? Now how a hash map will be better? Let's come to this point. Hash map will be better because it will depend, the size of the hash map will be proportional to the number of distinct values in our array, right? So the boolean array was taking a space which was equal to the size of the array, but we were facing a problem that what if it's a large array and all the values are 1, or probably the number of distinct values are very less as compared to the size of the array, right? So hashmap solves this problem, right? Hashmap solves this problem. What hashmap does is that, what you will do, suppose you have a map dot put. Suppose you go put, so you put a value current comma 1. Now again, you have multiple functions like dot put current comma map dot. These are functions, you can just go and look into this, but I'm just telling default current, right, plus 1. So what this function is doing, so it says that put a value, put an entry into the map where key is the current value of the current element in the array which I am traversing, and the value is sorry, here will be 0 as well. Here we have 0 as well, current comma 0, and the value will be get or default. Now get or default says that if you already have a key present, then return its value, else by default return 0, right? So this will return me the value that is present in the map, already present in the map. If it is not present, it will return 0, and then I'll add plus 1. So it is just Java implementation, nothing to learn in this. Probably when you will practice, you'll get to know. But here the logic says that now the size of the map is proportional to or equals to the number of distinct elements, right? So this is again an improvement, right? So in this case, again, what will happen, we will do one iteration of big O of n by and we'll put the values of and we'll basically put those values into hashmap along with the frequency, right? Big O of n one time, and second time what we'll do, again, sort of in worst case big O of n. Suppose we have all distinct values, so in worst case big O of n, else it will be big O of number of distinct values, right? So again, here also what is happening, we are taking time, the time complexity is big O of n, and space again goes to big O of n. Now n here is, sorry, not n is not the size of the array, but big O of number of distinct element. Sorry for n, big O of distinct element. So we can see what improvement we gain from approach 2. Here the space complexity was big O of size of the array. Here the space complexity is big O of number of distinct elements. Now number of distinct elements will always be less than or equal to the number of elements in the array, right? So this gives us a big improvement, right? This gives us obviously in worst case they both will be equal, but again we can see that we don't need to allocate a contiguous memory for the elements that are present in the array, right? So this was approach 3. Now what else can be done? Let's go to approach 4. Someone says that okay, in every approach what you are doing, either your time complexity is not good, or you are taking extra space. Somewhere you are taking boolean array, somewhere you are taking map. Can you do it without taking extra space? So yeah, we will discuss that in approach 4. What we can do, we can use sorting here, right? We can sort the elements, a simple thing. So suppose we have an array of 1, 2, minus 10, 100, 5, 4, something like this. Suppose this is the array, right? Now what we were doing, we were trying to check whether that particular element is present or not, right? What we can do, we can just sort it. So it becomes minus 10, then it becomes 1, 2, 4, 5, 100, right? We can just sort it. Now this is the array that we are getting. Now this time complexity will be big O of n log n, right? Now what we can do, we can start traversing this sorted array. Now one thing to note here is that we can have negative values in our array, right? So actually these negative values are of no use for us, So what we can do, we can start traversing the array and basically running our main logic when we see the first positive element, right? Suppose we have minus 100 here as well, minus 20, something like this. So what we can do, we can skip these elements in our iteration. So we can start from 0th element. It is negative, skip it. It is negative, skip it. It is negative, skip it. It is positive, okay, now run your main logic, right? Now what will be our main logic? Our main logic will be something like, after you have done these things, like you have skipped the negative elements, what we can do, int, we can do something like expected element. What is the expected first expected element? It's 1, right? So what we can do, for int I equals to, let's assume the current index is ind. Why current index? Because we have skipped these elements, right? So just for clarification, I'm writing ind I less than n, I plus plus, if array of I equals, or we can say, just a second, I'll just make it a little bit clean. Yeah, now this will work. So if array of I is not equal to expected element, this expected element, then just return expected element, right? Else obviously in every case you will be doing expected element plus plus. Simple logic, simple. The first element which we expect is 1. If we are not able to find that element, we return that this is the first positive number that is absent. Else we increment our expected number, it becomes 2. In next iteration we check, okay, is this equal to 2? If not, return 2, true. Else increment it, go to 3. You keep on doing this, right? If you come out of the loop, what will happen? So you know that, okay, we have basically got all the numbers in our array, right? So expected plus 1, expected plus plus, suppose it became 10, and when we, for the last iteration, when we went here, I plus plus became equal to n, the loop breaks. So again, after the loop also will return expected element, right? A very simple approach in this case, right? You just sort it, and you just do one traversal which takes big O of n. So overall time complexity will be big O of n log n, right? Getting it? Here we are not using any extra space. So this approach is a better approach as compared to what we have seen till now in terms of space complexity. Here space is big O of 1. But again, what if interviewer is not happy with this as well, or we want to optimize it more? We go to approach 5 now, and this is an advanced approach, right? And this type of approach can be used at multiple places. We'll discuss. I'll probably share a list of some questions that I did in my college days that were similar to this. It has been quite some time. I'll just find out certain questions based on this. Okay, so approach 5. So in this approach, someone says that you have used sorting. You have used sorting in some of your solutions. In some of your solutions, you have taken space, right? The best, so in this case, your complexity was big O of n log n. Here I am talking about space, time complexity. And here you went to on, but you took extra space. What if I ask you for a solution which has time complexity of big O of n, and space complexity of big O of 1? What if, right? So till now what you are doing, you were using sorting, which was taking big O of n log n time. You were using extra space, which was taking big O of n time, but it was also taking big O of n space, right? And it was taking big O of 1 space. This is space complexity. Now my requirement is just a second, sorry. So my requirement is, what you do, the time complexity of your solution should be big O of n and space should be big O of 1. I don't want you to take any extra space, neither I want you to do sorting and stuff, right? So what could be an approach? Now I know it's a little bit difficult logic, but let's see how we can go towards that logic. Now just see, the question says that you need to you don't need to use any extra space, right? You don't need to use any extra space. That means somehow I need to use the given array. I need to use only the given array or a couple of variables, but I can't take any extra space. I need to somehow modify my array so that I'm good to go. I don't need any extra space, right? This is about space. The expected time complexity is big O of n. That means I can't do sorting. I can't do sorting. Now, given this question, you just think there are two approaches. Either you sort the elements or you see whether elements are present or not by using a hash map or an extra array sort of thing, right? But by taking some extra space, right? And I can't sort. So I'll do one thing. Approach. One is sorting. Other is hash map. Now this increases your time complexity. So you can't go with this approach. Second one was hash map. Now hash map was taking extra space, right? Now what if I can use my current array in the form of hash map? What if I can do this? Because hash map was taking extra space and I can't take any extra space, but hash map is the only possible thing for us to do, because I need to check the presence of the elements, right? By sorting, what I was doing, by sorting I was attaining the order of the elements. Otherwise it was not possible. And what hash map does is it basically tells me the presence of the elements, because the elements are not ordered, right? But hash map or the boolean array, that is ordered with the help of indices, right? So that is why. So it gives me an intuition, it gives me some hint that okay, use the hash map approach in your given array only. Is it possible, right? So this is some sort of an intuition that you can get once you solve similar type of problem. So now what comes to the rescue is that we will be modifying our array. And we'll try to use it in the form of hash map, right? Now let's see how we can do that. Now suppose we have an array. I'll start with simple examples, okay? Suppose I have an array as 1, 2 and 3. These are the elements, right? Now what we need to do is that, suppose I'm just talking about this array, right? Suppose I somehow now there are n elements in the array and my answer can go maximum up to n plus 1. The reason being if all the n elements are present, right? Now for n elements I also have n indices here, right? I mean, forget about the values present in the array, but actually these values can be referred by using indexes 0, 1, 2, 3, goes up to n minus 1, right? For n elements I have n indices starting from 0 to n minus 1, right? Now, and we have already discussed our maximum answer can go up to n plus 1, right? Now what if I use the given array in the form of hash map and whatever values are present. Now if I have all the n values, then we are good to go, no worries. I'll come outside the loop and I'll return the n plus 1 answer. But even if a single element is present, even if a single element is absent, then that means my answer will be less than or equal to n, right? My answer will be less than equal to n. Like for example, if my array was 1, 2 and 4, now here n equals to 3, but now I can see I have an element missing here. That means if there is an element missing between 1 to n, my answer will always be less than equal to 3, and here I have 3 missing, so I will return 3 in this case. So the trick here is you have 1, 2 and 3. Why don't you use these numbers, obviously which are less than n, you can have numbers greater than n as well, but for this example all the numbers lie from 1 to n. Alright, what we can do is that we can use these numbers in the form of indices, right? What I mean to say is that, suppose we have 1 here, right? And again for indexing purposes, if the current value is cur, then I'll be going to current minus 1 index, just to clarify, because again 0 is not an answer and and we start indexing from 0, right? So that's why, for like, if I encounter value 1 in my array, if I encounter value 1 in my array, then I will be going to index number 0. If I encounter value x in my array, I will going to x minus 1 index, right? This is just for clarification. Now what I can do, I start traversing my array. I start traversing my array and I find the element. Okay, I have 1 here. What I can do, I can go to 1 minus 1 index. Based on this logic, I go to 1 lesser index. I can go to 1 minus 1 index and I can make this element negative, right? That means 1 is present here, right? 1 is present here. I go to 0th index and I make it negative. So my array becomes 1, minus 1, 2 and 3, right? I go to the second element. Now again it becomes 2 minus 1 equals to 1. So that means I go to the first index now, and again I make it negative, right? I make it negative. That means somehow there was some element present in the array because of which I was able to come to this index. This simply means this, that there was some number in the array that you were able to come to this particular index, right? You move forward, you encounter a value 3. Now what you do, you go to 3 minus 1, that is second index. And what is the second index? Is this one, right? You just negate this value, right? So that means what I have done, I have used the values present in the array, and basically I have visualized them as the indices of the array. I have gone to that location, I have gone to that position, and I have just negated it. Now again, you must be having multiple questions in your mind, that what if numbers are large, what if numbers are negative, but we are just considering this case. We'll come to those cases as well, but this is what happens, right? Now what will happen? In one traversal, I have done all this stuff. I've used my array in the form of Hashmap. Now in the second iteration, what I do, I start from the 0th index and I see which is the first non-negative number, right? Because if there is a non-negative number, that means I was not able to come to that particular index, right? I was not able to come to that particular index and negate the value. That means the number corresponding to that index was not present in my array, right? Suppose I was not able to come to index number, don't consider this example. Suppose I was not able, I have an array. After I do this, I get an array like minus 2, minus 3, I get 4, I get minus 5, something like this, just something like this, and for example minus 1, something like this, right? What does this represent? This represents that there is some value which basically send me to the 0th index. Now 0th index can be reached by a value 1 if that is present in the array. Okay, 1 is present. You go here, 3, right? You go here, this is negative. Now this can become negative only if I can come to this index. Now how I can come to this index? This index is 1. Now a number, if a number this is present in the array, then only I was able to come to this index. Okay, we are good to go. 2 is also present. I come here. Okay, this is the first number. This is the first positive number. Now I see this to come to this index. What is this index? 0, 1, 2. This is index number 2. And to come to this index, I needed a number this. And since this number was not present, that is why I was not able to come to this index, right? So what I do, I return, in this case, I return this one. Now that is 2 plus 1 was not present. So here we come to 3. That means 3 was not present in my array. Just taking an example. I'm just thinking 0, 1, 2, 3. In this case, what should be our answer? Minus 2 is here, minus 3 is here, minus 4 is here, minus 5 is here, minus 1 is here. So actually, since all these became negative, 0, 1, 2, 3, 4. Okay, actually I took an invalid test case, because we have index number 4. We had 3, but I did not make it negative. Okay, suppose this was 13. Suppose this was minus 13, right? Now it will be becoming, right? So this is the core logic that we will be using, right? Now let's come to tricky cases. What are tricky cases? The first case is, suppose we have negative values in our array. Like suppose we have minus 1, right? Then we have 2, then we have 3, something like this, right? These are the values in our array. Now our logic depends on that all the numbers are positive or not, right? Because then we will be able to transform those numbers into negative values. But there are already negative values present in the array. What we can do here? Now just think, the question says that we need to find the first missing positive number. That means the negative numbers that are present in our array, are just like acting as noise in our problem, right? This -1 is of no use for us. It is of no use, absolutely no use for us, right? Somehow, if it were, all I need here is that is a positive value, because this negative value is, it can never be my answer. If I get a positive value, and so that will help me in transforming this into a negative value, and helping me know whether corresponding to this index a number was present or not, right? You got the point. I'll reiterate. Suppose we have negative values like -1, -2, -100 and 1, right? Now in this case, just see these three indices. Actually, these three numbers are of no use for us, because these can never be our answers, right? Because these are negative values and I need to find the positive value. So even if I change the value of these numbers, it will not create a problem for me, right? It will not create a problem for me. And according to my logic, what do I need at these places? I need positive numbers, because my logic depends on the presence of positive numbers. Because if I have positive numbers in my array, then only I'll be able to traverse and run my logic and negate those numbers, right? So what I can do, now we discussed in the problem that for a given array of size n, just a second, yeah, I'm new to this, so yeah, this is creating some sort of problem. So if I have an array of size n, then what could be my, if all the elements are present, what could be my maximum answer? N plus 1. My answer can't go beyond n plus 1, right? It is not at all possible that my answer goes beyond n plus 1, right? So just think, suppose the size of my array is 10 raised to the power 7, right? If I convert this value into a value greater than this, a positive value, right, then obviously I'll not be having any problem, because I want positive value here, and I also know that the maximum possible answer can be n plus 1, where n is the size of the array. Now the size of the array is, suppose, 10 raised to the power 7. For simplicity, let's take the size of the array is 100, right? So I know my maximum answer can go up to 101. Suppose 1 to 100 is present in my array, and the size of the array is 100, so my maximum answer can go up to 101. What if I make this element as 102, 200, anything, any value greater than 101? Then I'm good to go. I don't have any problem. I can remove these noises, right? So what we can do here is that in the first iteration, we transform all the values into a value greater than n plus 1, right? So this -1, just so for this case I'm talking about, suppose I make it 200, just for the sake of simplicity, I make 200, and even all the values can be same, because these will be used as indices. The magnitude doesn't matter here. So here it was -1, I make it 200. Here it was -2, I make it 200. Here it was -100, I may again make it 200. Why? Because these numbers were negative. Now here I have 1, right? This was already positive. Now what I have done, using a trick, that knowing the upper bound of my answer, I have converted all the negative values into positive values, right? Now what we can do, we can run our logic. That we were running, right? What we can do is that we again start from here. We see, is 200 present? Like the value is 200, right? I need to go to index number 199, right? This is the core logic, right? Is 199 present? I mean, is the array big enough? No. Don't do nothing, right? Do nothing. Again you get 200. Is there 199 index present? No, the array is only of size 4. Don't do anything. Similarly, don't do anything. Come here. We have 1 here. Go to index number 1 minus 1, that is 0, right? Go here. Negate this value. Okay, we have traversed the array one time. Second traversal, we start from the beginning. We see, okay, this is a negative value. That means to come to this index, what was the value needed? 0 index plus 1. That is 1 was needed. Okay, 1 is present here. Come to this index, it's a positive value. That means my answer is dependent here. My answer is dependent on this particular index. What is this index? It is 1. What was the value needed to come to this index? It's 1 plus 1, that is 2. Now my answer will be 2 in this case, and that is the answer, right? Similar. So this is the approach that we can follow. I hope this was clear. And just yeah, I think this will cover all the cases. And obviously, while you are dealing with negative values, like for example, while traversing the array, now there are some tricky cases. Like for example, if you have an array, suppose your array is 1 1 1 1, just giving an example, right? So this will say that go to index number 0 and negate it. So you come and negate it. Now this will say again go to index number 0 and negate it. So it is already negative. Don't make it positive. You need checks here. What I mean by this is that suppose the index comes out to be IND. So go here and check if ARR of IND, if this is greater than 0, then only make ARR of IND equals to into equals to whatever it is. Just a second. Even I can't understand my writing sometimes, so yeah. So ARR of IND equals to -1 into ARR of IND, right? So this is a check that you need to add in your code, and then we'll be good to go, right? Let's just reiterate. I won't take too much time. So we started with a problem. The problem was find first missing number, positive number from an integer array. So and 0 is neither a positive nor a negative number. So we started with certain examples. We started with approach number 1. Approach number 1 said that okay, you run two nested loops where you try to search for each and every number. You search that, suppose you start from 1 to n plus 1, and see whether you are able to find that number or not, and then we return the value based on this. Now again, I'm seeing here we only need n here. Actually, we only need n here, because if we are not able to find, we return n plus 1, right? So only needed n, right? But this was having a time complexity of big of n square, right? So we moved to approach 2 because we wanted to decrease the time complexity. So in this case, we took a boolean array is present, and what we were doing, we were traversing the array, and we were basically marking the indices based on the values present in the array. So this was a better approach, but in this we were taking, so the time complexity reduced to big O of n, space basically increased to big O of n. Now here n is the size of the array. So we discussed that suppose our array is big and we have suppose just a couple of values, that the number of distinct values pretty less, then this is not the optimal solution. We are taking too much of space, right? So we moved to approach 3. In approach 3, what we did, we replaced boolean array with hashmap, because hashmap will take care of repetitive values. It will just increment the frequency, and the size of the hashmap will be proportional to the number of distinct values in our array. So this was a better approach as compared to approach 2. Here also our time complexity was big O of n and space was big O of number of distinct values, right? Now again, someone said that okay, you can't take an extra space. What do you do? So we move to a sorting approach. In sorting approach, what we can do, we can sort all the numbers. And then intelligently what we can do, we can skip the negative numbers. We can start traversing the array, and we can see which is the first element, which is the first expected element that is not present, and we can return our answer, right? So in this approach, what was happening, our time complexity was big O of n log n, because we were sorting the array, but the space complexity reduced to big O of 1. Great thing, right? Great thing. Probably one of the best approaches till now. Now constraints were added that you can't basically take extra space, and also the time complexity should be linear, big O of n. Now what you will do, right? That means this was the expectation. Time complexity is big O of n, space complexity is big O of 1. Now what we'll do? So we see that how we can approach this type of problem. So we saw that we used, so there could be two possible approaches. One was sorting, because we need order of the elements. We need to order the elements to find the missing element. Now sorting was not feasible, it was taking too much of time, right? The second thing was Hashmap. Hashmap was taking extra space but was giving us the answer in MIGO of n. So what we did was, since the question said that you need to do it in big O of one space, that means it gave us a hint that we need to use our current array, we need to somehow modify it to use it in the form of a hash map to check the presence of the values, right? So then based on this, what we did was, the values that were present in the array, we assumed them to be indices. So for a value current, we went to current minus 1 index and just negated that value. We took a simple example of 1 2 3. So here 1 was present, we went to index number 0, negated it. Here element 2 was present, we went to element index number 1, negated it. Similarly we did for 3. So we were good to go here. Now came some tricky cases. The tricky cases were, what if you have negative numbers? So for negative numbers, what we did, negative numbers were basically noise for us, right? But we needed those indices. So what we did, we knew that our maximum answer can go up to n plus 1. So what we did, we replaced all the negative numbers with, just a second, with a number greater than n plus 1, and we were good to go. What we did, we again ran our logic and we got the answer. Now one last thing that we did was, we took care of the approach that we took care of the case where suppose one element is present multiple times, right? Suppose even number of times. So the first occurrence of that element will basically negate the index. The second occurrence of the element will basically again negate that index, make converting into a positive value. So this was creating a problem. So then we discussed that we need to add a check that if the current value is greater than 0, then only you negate that index. Otherwise you don't touch this index, right? Because it tells that, okay, already a value made us to come to this position. Now we have got a second value which is again making us to come to this position, but this is sort of a repetitive thing for us, so we'll just skip it, right? So this was the approach that we follow. We discussed 5 approaches. So I'm pretty sure you learned something new from this video, and I'll try to come up with such, like I would say, case studies where probably we'll pick up a problem and we'll see what all can we learn. We'll start from brute force and we'll move to an advanced solution, and we'll see what are the hints, what are the time constraints in the question that can help us to come up with a relatively optimal solution. Not probably every time we can't come up with an optimal solutions. That will need practice, right? So the motive of this video was not to discuss or not to tell you a solution that you just go and deliver into the interview, but basically the intention was to develop an intuition how to approach these type of problems, right? And if you have any queries, then please do mention that in the comments. Also please do subscribe to the channel, like the video, and if you want similar content, then please mention that in the comments. I'll try to come up with such case studies. Okay, so yeah, take care. See you in the next video. Bye bye.